Okay, so this is an exam question. It's really tricky. I'm going to try and explain through it. It's quite hard just to see it on the screen. So I've kind of visualized it for you. You need to also be looking at the question at the same time, really, to help you with this. Um, and I've given you an example Google Sheet for you to be able to tick the boxes and go through and trace it yourself and see if you get to the right answer. But you need to work through this and practice it. This is the hardest trace table you'll get. This is the kind of thing that could come up in the exam. It did come up last year, so it came up in 2019. 2020, we're going to skip a year. We don't know what's going to be in 2021, so you might be lucky because it is complicated. So here's a graph they've given us. It's not letters for nodes, it's numbers for nodes. And we're going to do a depth first search, and it wants to find out if there's an exit in a maze. So we looked at a maze example before. So we're going to try and get from 1 to 7. We're going to do the search to see if there's a link going all the way through there and taking us out. Now, we can see that by looking at it, but we need an algorithm to do it so the computer can see that and find it out for itself. Now, here is the algorithm it's going to follow. It's called DFS, depth first search. We give it the current vertex and the end one that we're looking for. We've got a list called discovered. So everything that gets discovered gets put into this list, and we index it by the vertices. So because they're numbered, it works quite nicely here. So the first thing we'll do, if we put 1 in, it puts discovered position 1 and turns it to true. So it holds a true and false value in that list. And then we're going to see if the V we're on is the NV, and if that's the case, then found becomes true. Otherwise, we loop through each vertex which is connected to V. So that could be held in a dictionary. So 1's connected to 2, 2's connected to 1, 3, and 4, 4's connected to 2 and 5, and so on. So it's going to loop through those, and each time it loops through, if it's not in the discovered list, it's going to recall this function here and go through again with U. So U then becomes the V here, the position that you're on. So it will do it for 2, then it will do it for 4, then it will do it, and so on. And then it should give us the answer at the end. Now, I'm going to do it with a trace table. I've done it as a Google Sheet for you. This is how it appeared in the exam. I'm just going to colour the box to indicate that something's true. So first time we call it with 1 and 7. So these are our calls to the function down here. And they give us all this. They give us V and they give us U in the orders that we would discover them as we go through. The NV is what we're aiming for. We're going to try and get there. This is the list here of the discovered lists and the completely explored. And then this is where found becomes true when we actually find number 7. So we're going to go through each of these and we're going to populate those as we go down. So once you've got a green in there, it's not going to change. But you just put a square to show it. So there's only one node off 1. So U becomes 2. The for loop will loop through the list of connected nodes. So we will go to 2. So 2 is the next thing connected. So we call it, and what with 1 and 7, V's 1 and 2 is the next thing that's connected to it. So once we get to 2, we go in there and we call. First off, we make the position 1 discovered. We found it because we've called it. The first thing we do is discover it. We go to 2, we discover 2. 2's connected to so 2 becomes discovered. There are 3 nodes connected to 1, 3, and 4. It starts looping through the list. 1's been discovered, so it next goes to 3. Now, it goes to 3. There's nothing off 3. So it calls 3. It goes to 3. It does the call to 3 and 7. It's at this point that 3 becomes discovered as it recurses through. And then it's only connected to 2's already discovered. So the for loop doesn't loop anymore. And then therefore position 3 and completely explored becomes true. So we've changed that to true now. So we've gone down to that length, to the end of that branch to 3, and it's been completely explored. So then from there, we're going back to where we were before, which is the 2, 7. We're in that loop. We're looping through. So we had 1, which we looked at, 3, which keeps disappearing, was connected to 1, 3, and 4. We looked at 1, we looked at 3, and the next thing is 4 to visit. So we need to start a new recursion from here, which is DFS 47. So we get to there, and we're on this line here. So we've got to put the 4 in. So 4 now becomes discovered, and then we loop through what's connected to 4. And then we're going to recurse again with node 5. So it's connected to 5. So then what we need to do is to recurse again to node 5. 5 becomes found. And then from 5, 5's connected to 4, 6, and 7. 4's been seen before here. So we need to go to 6 and 7. So we recurse to 6. 6 is only connected to 5. 5 discovered already, so 6 becomes completely explored, and then we're going to then recurse back to this stage here and back to where we were before, and then we're going back to carrying on with the list of things connected to 5. 5's connected to 4, 6, and 7, so 7's the next one we look at there. So 5, 7, we're looking at position 7 here, so U becomes 7, and then 7 is then discovered. 7 is completely explored because there's nothing connected to it. And then found becomes true. And what happens next is we then recurse back out. And as we're recursing back out, the completely explored boxes become filled in. And as you can see, then we've got all the way back to the top recursion up here. Okay. So these are the calls to the function, and then this is, and you can see it recursing all the way back out as you get to the bottom at the end there, coming back to this one here. So it stops there, and then you've got your discovered list, your completely explored list, everything there, and you've got your found equals true. Okay, tricky stuff. Have a go at doing that on the one I've given you, and then I've got the answer there as well for you too. Okay.